This is 2.1, analyzing piecewise functions. So you have your essential question here. How do you determine if function is increasing or decreasing? How do you determine the domain and range? So increasing functions. A function is increasing when the y value increases as the x value increases. So just a few examples of increasing functions. You can have lines. That's an increasing line. It's going, you can kind of see if you're moving from left to right, it's going up. You can have curves. Even if they're kind of like flattening out a little bit, it's still increasing, right? As you're moving left to right, you're going up. And you can have kind of like peakier curves, like so. As you're moving left to right, you're going up. So as long as you're going up, that is an increasing function. Okay. Then, I guess I'll highlight that. That's a keyword there. Next keyword is a decreasing function. So a function is decreasing when the y value decreases as the x value increases. So as you're moving left to right, you're going down. Like so. That's a line that is decreasing. You can have a decreasing function that's kind of leveling out, but is still decreasing. And you can have one that's more like a drop off. That's still decreasing, right? As you're moving left to right, you're slowly moving down, and then you're quickly moving down. Okay. So, state the interval. All right, that's an important thing. So before we move on, realize that we talk about domain intervals. Whenever they say state the interval on which f of x is increasing, or state the interval where something is happening, it's always a domain interval. So remember, a domain are the x values. So we're describing a position on a graph using the x values. All right. So where is it increasing and where is it decreasing? All right, so we have increasing. So this is flat, it's not going up, so that's not anything. This is going down. So remember, we always move left to right. So kind of move your pencil across your graph, see what's happening as you move. So it's flat, this is down, so that's actually going to be where it's decreasing, and then up. This is where it's increasing. It has an arrow at the end, that's important. We always use open intervals. Open intervals meaning no brackets. Okay, so you don't have to worry about brackets or not. It's always going to be a parenthesis with these intervals. So it's from 3 to infinity. And the reason we use open intervals is if you look at this point, I'm decreasing before it, increasing after it. So how can we say whether this point is increasing or decreasing? We can't say. So we just leave it open, meaning a parenthesis. Decreasing. So we already said where it's going down is right here. So that's from 2 to 3. Notice I'm using the x values to describe it. So from 2 to 3. The increasing was from 3 on to infinity because it's going right forever. And there's actually a third thing. It doesn't ask for it, but you do need to know, what about where is it constant? Where is it flat? So increasing is going up, decreasing is going down, and constant is when it stays flat. And that is right here. So that is from -5 to +2. Once again, using the x values. -5 to +2. And there we have it. So next, we're going to talk about two more things, relative max and relative min. A relative max is a point where f of x is increasing before and decreasing after. Okay, and it can be like a V-shaped, increasing then decreasing. Notice this point would be a relative max because I'm increasing before, decreasing after that point. It can be curved, increasing then decreasing, so like a U-shaped. It can be a mixture, so maybe I have a line and then a curve, like that, or maybe I have a curve and then a line, kind of like that. These are still all relative maximums, okay? Notice it is not saying the highest point of the graphic. We're not looking at the maximum height or something like that. This is increasing before, decreasing after, a relative maximum, relative to the slope of the line. Okay, so increasing then decreasing. Then we have relative minimum. It's the opposite. So it is decreasing before and increasing after. So that point would be a relative minimum. Okay, it could be a U shape, just like before, the point right here, the bottom, increase or decreasing then increasing. It can be something that's straight and then curves. That point, it's decreasing then increasing. It can be something that curves and then is straight. That point right there, decreasing then increasing, right? Once again, it's not the minimum height, not the lowest point. It is a point that has decreasing before, increasing after. So be careful about that. Okay, looking at example 1 before we get to example 2, notice you have a point right here. It's constant then decreasing, so that's neither. This point right here, it's decreasing then increasing, so that would be a minimum, a relative minimum. Okay, so in example 2, it says state the coordinates. So notice it is coordinates. So x comma y, coordinates of any relative min or max. So min, max. So do not confuse the intervals with the parentheses. These are intervals, domain values, with coordinates x comma y. So they're going to look very similar, but mean very different things. Got to start recognizing these keywords. So my minimum, it has to be decreasing before, increasing after. So that point right there, that would be a minimum, and that's at coordinates 2, -2. The maximum, that point right there, it's increasing then decreasing. So that's at 1, 4. And there we have it. So example 3, we got a little bit more going on here on example 3. So it state the open intervals where it's increasing, decreasing, state the domain and range, state the relative minimums, state the relative maximums, and we are going to skip part F. We're not going to deal with that this year. We don't have to write the equation of the piecewise function, so you can cross that out. So first, it is the open interval where we are increasing, open interval where we're decreasing, coordinate where we're relative minimum, and coordinates for relative maximum. All right, so increasing. So there's going to be more than one now. Notice I'm decreasing, so always move left to right. So I'm going down, up. So from -3 to 0, remember we use x values, not coordinates, but x value intervals. So from -3 to 0, I'm increasing, decreasing, and then I'm increasing again here. It doesn't show it, but this is supposed to have an arrow, so you can add an arrow. There's no end point, so assume it's an arrow when there's no end point. Okay, we have to add another one, so we need a U. Remember, that means there's more. So this is going from 3 to positive infinity, because that is to the right. 3 to infinity. Okay, open interval where it's decreasing. So we have decreasing here, that is from -infinity to -3. U, we have another section right here from 0, be careful, 0 to 3. Okay. Then it asks for domain and range. The domain of this function, I'm going how far left. There's all the x values in between. How far right. Done. Range, how far down. My lowest point is -3 included. Okay, hopefully you're starting to get better at this after we've had a whole unit talking about it. To how far up, all the y values are included. And notice this arrow goes up forever. This arrow goes up forever, so it is positive infinity. Then we have coordinates. So this is x, y ordered pair, x comma y of any relative minimum. Okay, so that looks like a minimum to me, decreasing then increasing. That looks like a minimum, decreasing then increasing. So we have the coordinates, -3, 0, and the coordinate 3, -3. And the last one, maximum, looks like that point right there. It's increasing then decreasing, so that's it. That is at the coordinates 0, 3. Okay, so you got to make sure you're really careful. When is it an interval, talking about domain values, and when is it a coordinate? Make sure you understand they look very similar, right? This and this look like the exact same thing, but they mean completely different. This is an interval from -3 to 0, talking about a section of the graph. This is coordinates, talking about -3, 0, the specific point. So be careful about that. And then we get to our last one. Once again, cross out F. We will not be writing equations. Okay, so we have a little bit more complicated looking one. Once again, we have the intervals for the increasing, decreasing, and we have the coordinates for the relative max and min. Okay, so starting with increasing, decreasing, so moving left to right. So this is decreasing, and then it switches right here. It doesn't have a point, but we still need to understand that right there at that point, which I can add it in, that's where it switches, right? From decreasing to increasing. So I'm increasing from -2 to 0. Okay, and then it has a gap, so we're not going to include that, so we put a U. And it's actually increasing again, right? From 0 to 5. Talking about x coordinates, -2 to 0. Then it has a little gap, but then it picks right back up from 0 to 5. And then notice it is constant there. So that's not neither of them, right? Next is decreasing. So I'm decreasing from -infinity to -2. And that's where it stops. And all the other ones are either increasing or constant, so that's it. State the domain and range. All right, domain is left to right. So how far left? Was an arrow pointing to the left, so -infinity to, okay, I'm going, all the x values are included. It looks like I have a hole, but remember, as long as that x value is included somewhere else, which it is, an x value of 0 is included right there, I can continue. Okay, looks like I have a hole, but I have to check, is that x value of 5 included somewhere else? It is, so I can continue. And then I end on the hole at 8. So that would be not included, 8. All right, then we get to the range. Okay, how far down? There's the lowest point. It's at -2 included. I actually get to that point. It's not a hole, it's not an asymptote. My graph gets to there. Even if I didn't draw in that point, it's still getting to the value of -2. Okay, so make sure you understand that it doesn't have to have a point. As long as it gets to that value, it's included. No asymptote, no hole. All right, and now how far up? So we got to check all of these things. So this one, a hole, but it is included in my graph. A y value of 2 is included in the graph right here, right? I passed through it right there. Okay, I have another hole, but I have lots of values included right here, and that point, and this point over here. Okay, I have another hole, but it's included right here, right? I'm going up. And you can kind of notice -2, and then this line has no breaks in it at all. It means every y value is included, arrow pointing towards up, so it's going to be infinity. All right, and now finally we need mins and maxes. This time we're talking about coordinates, x, y. So minimums have decreasing then increasing, so that's a minimum. And that might be it. So coordinates, -2, -2. Okay, maximums. Well, I'm decreasing, then I'm increasing, then I'm increasing, then I'm constant. So the answer is none. There's no point that is increasing and then decreasing directly after it. Okay. If you come across things with breaks, to be maximums or minimums, it needs to be continuous. So if it has a break, it can't be a minimum or a maximum. Okay, so understand that. There's no minimum or maximum when there's a jump in the graph. It has to be continuous, connected. Okay? And since we're not writing equations, that's the end of 2.1, so make sure you write your 3-sentence summary.